Hello, my name is Evan. I wanted to go into a little bit more detail on the Configurator tool within Simplicity Studio. Configurator allows you to graphically configure an MCU using drop-down boxes, text fields, and checkboxes. Configurator also has built-in error checking and calculators to make your life easier. This video is going to go through a brief tutorial on how to use Configurator with our MCU products.
You create a Simplicity Configurator project from the Simplicity Studio screen by selecting the device you want to use in the Product area and clicking the Configurator tile. From within the Simplicity Studio IDE environment, create a new project by selecting File, New, Silicon Labs MCU Project from the menu bar. After creating a new Simplicity Configurator project, Studio will automatically switch to the configuration perspective. The available views in a Simplicity Configurator project are Mode Transitions, which is used to define different MCU peripheral initialization states, such as default mode from reset and other optional modes, for example, low power mode. This editor can also be used to define transitions between states. Port I/O, which is used to configure the crossbar and port pins, and Peripherals, which is used to configure hardware peripherals such as ADCs, timers, PCAs, etc. To configure a peripheral, click on the Peripheral box. This will select the peripheral and open the peripheral in the Properties view. Properties can have either a drop-down menu with the available selections or a text input box for a numeric field. The Port I/O tab displays a package drawing for the selected device. This tool enables easy configuration of the pins of the device, both for the crossbar and for peripherals with fixed pin assignments. Multiple pins can be selected and configured at once using Control or Shift, or by dragging and selecting with the mouse. Modes define different states of peripheral configurations. For example, an application may want to use two configurations of the ADC and timer 2 with different input pins and sampling rates. These two configurations can be treated as separate modes with separate initialization sequences. The movements between these modes are called transitions. Adding a transition causes the generation of a corresponding function that application firmware can call to initiate the transition between modes. Configurator generates only the transitional code from peripheral to peripheral between modes. For example, if only the timer reload value and ADC input mux selection differ, then those are the only two properties touched by the transition code. To see the differences between two modes, right-click on the mode transition and select Show Differences. This provides a report of all the different property values between the modes on a module-by-module basis. Simplicity Configurator automatically validates register configuration values and displays any errors, warnings, or information items in the Problems view. Double-clicking on an entry in the Problems view will automatically display the property that raised the problem in the Properties view. Any peripherals that contain a warning or error will be highlighted in yellow for a warning or red for an error, and the associated property will have a corresponding warning or error icon. Once the highlighted property is updated, the associated warning or error will disappear from the Problems view, indicating that the problem has been solved. If a warning or error doesn't apply to the project, it can be permanently deleted from the project by right-clicking on the entry in the Problems view and selecting Delete. To generate code for a peripheral, enable the checkbox for that peripheral in the Peripherals tab. Saving the project will automatically generate code for all selected peripherals and port pins. This code generates into the initdevice.c, initdevice.h, and interrupts.c files. Each hardware register has a section in the initdevice.c file tagged with the register name and register description. These tags indicate that everything in between is automatically generated, so any code added manually between these tags will be deleted on the next Configurator project save. Code can be added in between these tags, however, and this code will not be overwritten. For registers that are modified from the reset value or the value in the previous mode, the tags include comments that update based on the settings for the register. Now let's move into the C8051 F850 walkthrough. This walkthrough configures the C8051 tool stick to brighten and dim an LED using a measured potentiometer reading. Create a new configurator project and disable the watchdog timer to remove the error. Configure timer 2 to overflow every 1 kHz. This timer will serve as the ADC startup conversion source. The calculators in the configurator indicate that the overflow frequency will be approximately 1 kHz. Configure the PCA for 8-bit PWM mode. Configure the ADC to use timer 2 as the startup conversion source in 8-bit mode with 1x gain. The ADC should measure ADC 0.10 or P1.2, which is the pin for the potentiometer. Enable ADC interrupts. Now let's configure the pins. The LED is on P1.0, so we enable the PCA CEX0 output on the crossbar and shift it to P1.0. The PCA output should be push-pull to drive the LED, and the ADC input should be analog and skipped on the crossbar. Configurator generates code anytime the project is saved. Then, we add in 2 lines in the ADC ISR to copy the ADC reading into the PCA PWM output. Now we build, run, and rotate the potentiometer. That's how easy it is to use Simplicity Configurator to initialize the hardware and build your application.
For more information on Configurator or to download Simplicity Studio, please visit scilabs.com.